Dear students, Namaste and welcome back to a new mathematics session. In the previous session, we have solved questions from exercise 13.1. Hope you have revised well. And in today's session, we shall discuss first four problems from exercise 13.2. Let's move on to the topic. Before starting the session, let's recall the formulae from the chapter surface area and volume. The first shape is cuboid. Length is represented by the letter L, breadth is represented by B, and height is represented by H. Then the volume is L into B into H. Lateral surface area is 2H into L plus B, and the total surface area is 2 into LH plus BH plus LB. Next shape is cuboid. The side of the cuboid is represented by the letter A. Then the volume is A cube. Lateral surface area is 4a square and the total surface area is 6a square. Next is a right circular cylinder. The height of the cylinder is represented by the letter H and the radius is represented by the letter R. Then the volume is pi r square H. Lateral surface area is 2 pi r H and the total surface area is 2 pi r into H plus R. Next one is a right circular cone. The height is represented by H. Radius is represented by the letter R and the slant height is represented by the letter L. Then the volume is 1 by 3 pi r square H. Lateral surface area or curved surface area is pi rl and the total surface area is pi r into L plus R. Next shape is sphere where the radius is represented by the letter R. Then the volume is given by the formula 4 by 3 into pi r cube. Curved surface area is 4 pi r square and the total surface area also the same formula 4 pi r square. Next shape is hemisphere. Like the previous one sphere, here also radius is represented by the letter R. Then the volume is 2 by 3 pi r cube and the curved surface area is 2 pi r square and the total surface area is 3 pi r square. Next, let's discuss first question from exercise 13.2. The question is, a solid is in the shape of a cone standing on a hemisphere with both the radii being equal to 1 centimeter and the height of the cone is equal to its radius. Find the volume of the solid in terms of pi. Let's go through the question once again. A solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter. Means the shape is a cone standing on a hemisphere and the radii is equal to 1 centimeter and the height of the cone is equal to its radius. Height is equal to the radius. Find the volume of the solid in terms of pi. So let's have a visualization of the solid. That is, here there is a cone standing on the hemisphere and the radius is 1 centimeter and the height is equal to its radius, means height is equal to 1 centimeter. So we have to find out the volume of the solid. So volume of the solid in the sense we have to calculate the volume of the cone and we have to calculate the volume of hemisphere and we have to add both these volumes. Then we will get the volume of the solid. Before going for calculation, let's write down the given measurements. That is, in case of cone, we have radius r is equal to 1 centimeter and height h is equal to 1 centimeter. Here condition is there, the radii being equal to 1 centimeter and the height of the cone is equal to its radius. So height and radius are same in case of cone. Next, in case of hemisphere, radius is 1 centimeter. So hemisphere is having only one dimension, that is the radius that we have written here. Next, total volume of the solid that I have explained to you before, that is volume of cone plus volume of hemisphere. So we have to go for finding the volume of cone. We know the volume of the cone formula, that is 1 by 3 pi r square h plus volume of hemisphere is 2 by 3 pi r cube. So we must by heart all the formulas, then only we will be able to substitute according to the question. So let's substitute the values of r and h here. That is 1 by 3 pi into r and h, we know both it is 1 centimeter. So 1 square into h is 1 plus here 2 by 3 pi r cube. Here also radius is 1 centimeter. So 2 by 3 into pi into 1 cube. That is 1 by 3 into pi. Here 1 into 1 is 1. So we will get in the first term there is only 1 by 3 pi plus The second term there is 2 by 3 pi. Here we have to keep pi as it is because we want the answer in terms of pi. So we don't want to substitute the value of pi. Then when we take 3 as LCM, we will get 1 plus 2 in the numerator because there is a same denominator. So we can add the numerator. 1 plus 2 is 3. So 3 by 3 pi. So 3 and 3 will be cancelled. So finally we will get as pi centimeter cube. That is the volume of the solid. Volume of the solid is equal to pi centimeter cube. That is the answer. Next, we shall discuss question number 2 from exercise 13.2. The question is, Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 cm and its length is 12 cm. If each cone has a height of 2 cm, find the volume of air contained in the model that Rachel made. Assume the outer and inner dimensions of the model to be nearly the same. Let's go through the question again. Rachel, an engineering student, was asked to make a model shaped like a cylinder with the two cones attached at its two ends. Means here there is a cylinder and two cones are attached both its ends. That is what the shape. And it is made up of aluminum sheet. And here it is mentioning that assuming the outer and inner dimensions of the model to be nearly the same. Means the thickness is negligible. And the dimensions are given to us. Diameter of the model is 3 cm and the length is 12 cm. Length of the entire shape, that is 12 cm. And the cone height is given to us 2 cm. We are asked to find out the volume of the air contained in the model. That means volume of the air in the sense we have to find out the volume of the solid. Means whatever shapes are there, that shapes volume we have to find out and add. Let's visualize the question. There is a cylinder and the two cones are attached both its ends. And the entire length of the model is 12 cm. And the diameter, it is given to us 3 cm. Diameter comes here where there is circle, 3 cm. Then here it is given to you height of the cone, that is 2 cm. That also mentioned here. Then by using this height, we can calculate the height of the cylinder. Means the total length is 12. From 12, if we subtract these two and these two, we will get the height of the cylinder. That we will do it later. Let's write the given dimensions of cylinder. That is diameter of cylinder is given to us 3 cm. From here radius we can calculate. Radius is equal to diameter by 2, that is 3 by 2. Height of the cylinder, that is equal to, as I mentioned before, total height is 12. From there we have to subtract these 2 and these 2. So 12 minus 2 minus 2, that is equal to 8 cm. Next is cone. So radius r is equal to diameter by 2, that is equal to 3 by 2. Then height is given to us, it is 2 cm. Let's go for calculation. Total volume of the model means this model contains two cones and a cylinder. That means volume of cylinder plus 2 into volume of cone. There are two cones are there, so just multiply 2 into volume of one cone. Let's recall the formulas. Volume of cylinder is pi r square h and volume of cone is 1 by 3 pi r square h. You can write down these formulas on the corner of your answer sheet or notebook. Then substitution part is enough here. That is pi r square h. Pi is 22 by 7 into r. R is 3 by 2 square into h is 8. Here pi value 22 by 7 we are substituting. And in the previous question we did not substitute pi because there it was asked to keep pi. Means we want to write the answer in terms of pi. So there we did not substitute. But here we are substituting because nothing is mentioning about pi here. Then plus second part 2 into volume of cone 1 by 3 into pi into, that is 1 by 3 into pi value 22 by 7 into radius, that is 3 by 2 square into height is 2. Height of the cone is 2. Let's go for calculation. That is 22 by 7 into 3 by 2, that is 9 by 4 into 3 by 2 square is 9 by 4 into 8 plus 2 into 1 by 3 into 22 by 7 into 3 by 2 is 9 by 4 into 2. Here let's go for a little bit of cancellation. That is here 4 and 8 we can cancel it 2, and here 3 and 9 we can cancel it 3 times. And instead of going for calculation, normal calculation, we will go for factorization here. Let's take the common term here out. 22 by 7 and 22 by 7. Both the terms are having that 22 by 7 common. Let's take out 22 by 7. And if you take 22 by 7, in the first term there is 9 into 2, that is 18 balance. And in the second term, little more terms we can cancel. Means here this 2 and 4 we can cancel 2 times. So here 2 is remaining. That 2 and this 2 can be cancelled. Means 2, 4 and this numerator 2 will be cancelled. And 22 by 7 is outside. There is only 3 balance in the second term. So it is plus 3. So 18 plus 3. 18 plus 3 is 21. So 22 by 7 into 21. 22 by 7 into 21, and we will get the final answer as 66 centimeter cube. That is the volume of the model. Here volume of air contained in the model is 66 centimeter cube. That is the answer. Next we shall discuss the third question from exercise 13.2. Gulab jam contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jams, each shaped like a cylinder with two hemispherical ends with a length 5 cm and diameter 2.8 cm. There is a figure given to us. Let's go through the question. Gulab jam contains sugar syrup up to about 30% of its volume. So 30% of the volume of the gulab jam means it's sugar syrup. We have to find out approximately how much syrup would be found in 45 gulab jams. And each gulab jam shape is given to us. It is a cylinder with two hemispherical ends, and the dimensions are given to us: length 5 cm and diameter 2.8 cm. Let's see the given figure. There is a bottle of gulab jams and sugar syrup is there up to this much. That is maybe the 30% of its total volume. Then each gulab jam's shape is given to us. That is a cylinder and two hemisphere are both the ends. And the length of the gulab jam, that is 5 cm, and the diameter means where there is a circular portion, there it comes, that is 2.8 cm. So let's write down the measurements of a cylinder. Here there is one cylinder and two hemispheres. So first one is cylindrical portion, that is the radius of cylinder is 2.8 is the diameter. So 2.8 divided by 2, that is 1.4 cm. Here we can divide 2.2 by 2.8 by 2 because we know that 1.4 it is a multiple of 7. So 22 by 7 we can use it for cancelling this 1.4. So we can divide and keep the answer. It's not a problem. Height of the cylinder, that is equal to 5 minus, here you can see this portion is 1.4. That means the radius of the hemisphere. And here also that radius will be coming, that is 1.4. That means from the total length 5, here 1.4 is removed, here 1.4 is removed. That means 2 into 1.4 is removed from the total length 5. That we will get the answer as 5 minus 2.8, that is equal to 2.2 centimeter. That is the height of the cylinder. So height of the cylinder is this portion, that is 2.2 centimeter. Next is hemispherical portion. Only one dimension is there, that is radius 2.8 by 2, that is 1.4 centimeter. So volume of the gulab jam is equal to volume of cylinder. There is a cylindrical portion, that is plus volume of two hemispheres, that is one hemisphere here at one end and another one is at the another end. So 2 into volume of hemispheres. So let's recall the formula, that is volume of cylinder, that is pi r square h, and the volume of hemisphere is 2 by 3 pi r cube. Let's substitute the values here. Volume, that is pi r square h, 22 by 7 into radius is 1.4, that is 1.4 whole square, into height of the cylinder, that is 2.2, plus volume of hemisphere is 2 by 3 pi r cube. Let's substitute it. 2 into, there are two hemispheres are there, so 2 into 2 by 3 into pi. Pi is 22 by 7 into r cube, that is 1.4 the whole cube. Here we have to go for calculation and we have to be very careful because some division and multiplication of decimal numbers also will be coming. So the calculation must be very accurate. That is 22 by 7 into 1.4 square. We can write as 1.4 into 1.4. No need to multiply here together because after cancellation we will go for multiplication. After reducing it into smaller quantities, then we'll go for cancellation. Then we'll go for multiplication. That is better. So 1.4 we can write it as 1.4 into 1.4. Here 2.2 plus 2 into 2 by 3 into 22 by 7 into 1.4 the whole cube. We can write as 1.4 into 1.4 into 1.4. So wherever possibilities are there, let's cancel it. Here 7 and 1.4 we can cancel. We will get as 0.2. 7 and 14 2 times. 7 and 1.4 is 0.2 times. Here also 7 and 1.4 we can cancel 0.2 times. And here there is no denominator. And here there is a denominator 3. But there is no number can be divisible in the numerator with 3. So let it be same. No need of going for any cancellation. That is here 2 into 0.2 into 1.4 into 2.2. Once again 22 into 0.2 into 1.4 into 2.2. These four quantities you have to multiply. You have to take a rough sheet of paper or you have to do it on the right side of your notebook. Multiply this quantity. That is compulsory. Then you will get the answer as 13.55. You do not copy this answer. You must multiply it and then select that answer and write it. It must be 13.55. And here when you multiply the numerators, 2 into 22 into again 2 into 0.2 into 1.4 into 1.4. So many quantities are there. Here you can see 2 into 2. 2 into 2 is 4. Then 22 into 4 is 88. Then you have to multiply with 0.2. Then you have to multiply that with 1.4. Then you have to multiply with 1.4. After multiplying all these quantities, you will get the answer as 34.5. Then denominator there is a 3. I repeat, you should not copy this answer and you must do the calculation and then write. Otherwise, you will be facing problem when you solve these type of questions in the examination hall. Then 13.55 plus 34.5 by 3. 34.5 by 3 will get us 11.5. You have to go for division. Then when we add these two quantities, you will get us 13 plus 13.55 plus 11.5 will get us 25.05 centimeter cube. We have got the volume of 1 gulab jam is equal to 25.05 centimeter cube. And volume of 45 gulab jams. In the question it is given to us in one bottle there are 45 gulab jams. So volume of 45 gulab jam is just volume. What volume we have got multiply with the 45. So 45 into 25.05. Let it be same. No need to multiply now because there are calculations. We will do it together. It is given that the quantity of syrup in gulab jam is 30%. That is given to us in the question. Quantity of syrup in the gulab jam is 30%. So syrup in 45 gulab jams. We have 45 gulab jams in the bottle. So syrup in 45 gulab jam is 30% of the volume. So 30% of the quantity. That is we have 45 into 25.05 is the volume. So 30% of 45 into 25.05. That is equal to 30% means 30 divided by 100. Just division with 100. That is what the percentage symbol means. 30 by 100 into 45 into 25.05. Here division by 100 only. So it is quite simple. Just multiply the numerators. 30 into 45 into 25.05. Peacefully you have to multiply it. Please do not copy this answer. So just multiply this one and divide with 100. Means just move 2 places to the left. That is we will get us 338.175 centimeter cube as the syrup or the volume of syrup in the gulab jam or 45 gulab jam bottle. Then we have to round off this answer. That is syrup in 45 gulab jam is equal to here 338.175 means it is very close to 338. And we will round off this answer as 338 centimeter cube. So syrup in 45 gulab jam is equal to 338 centimeter cube. That is our answer. Next we shall discuss the fourth question from the same exercise. A pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. The dimensions of the cuboid are 15 cm by 10 cm by 3.5 cm. The radius of each of the depressions is 0.5 cm and the depth is 1.4 cm. Find the volume of the wood in the entire stand. See the figure. There is a figure given to us. So let's see the figure. There is a figure. A pen stand is made of wood, is in the shape of a cuboid with 4 conical depressions to hold pens. This is the pen stand with the pen. This is only the pen stand. So this is what it is mentioned here in the question, not this one. So here there is a cuboidal shape and there are 4 conical depressions. 1, 2, 3, 4. Depression in the sense, we have already learned this one in the previous exercise. Depression in the sense, the particular shape is removed from the cuboid. So the cones, 4 cones are there. 1, 2, 3, 4. These 4 cones removed from the cuboid. That is the way the pen stand is made. And the cuboidal shape dimensions are given to us 15 by 10 by 3.5 centimeter. And the radius of each of the depression, is means cone. It is given to us 0.5 centimeter, and the depth means height is given to us. Height of cone is given to us 1.4 centimeter. It's not necessary to draw again a diagram. It is quite clear from the given picture itself. There is a cuboid and 4 cones are removed from the cuboid. We have to find out the volume of wood in the entire stand. Quite simple. Volume of wood we can calculate. Volume of wood is equal to volume of cuboid minus 4 into volume of cone, because these cones are removed from the cuboid. So we have to minus it, these 4 cones volume. So cuboid dimensions, it is given to us. Length is 15 centimeter, breadth 10 centimeter, and height is 3.5 centimeter. And for the cone, it is given to us the dimensions. Radius 0.5 centimeter and height 1.4 centimeter. All dimensions are given to us directly. We can write it from the question itself. As I mentioned before, the cones are made inside the cuboid pen stand. Volume of wood in stand is equal to volume of cuboid minus volume of 4 cones. So this volume of cuboid, and since these 4 cones are removed from the cuboid, we have to subtract it, minus volume of 4 cones. That is, volume of cuboid is L into B into H minus 4 into volume of 1 cone, that is 1 by 3 pi r square h. Here L, B, H and R, H, both shapes are having different dimensions. So just I am substituting the formula here itself. That is equal to L is 15, breadth is 10 and height is 3.5. Minus 4 into 1 by 3 into pi is 22 by 7 into radius. Radius is 0.5. So 0.5 into 0.5 into height is 1.4. That is written here. Then we can go for a little bit of calculation. This 7 and 1.4 we can cancel and we can write it as 0.2. Then that is here 15 into 10 into 3.5. Like in the previous question, just multiplication is there. You have to multiply. Please do not copy. Simply multiply it on your notebook and write it. 525 will get minus. Numerator, when you multiply, you will get 4 into 22 into 0.5 into 0.5 into 0.2. If you multiply these numerator quantities, you will get as 4.4. Denominator, there is a term, that is 3. That is equal to 525 minus 4.4 by 3. You have to divide it at least 2 decimal places. You have to divide. 4.4 by 3 you will get as 1.47. That is equal to, when you subtract, you will get 523.53. So the volume of wood in stand is 523.53 centimeter cube. That is our answer. Dear students, today we have discussed first 4 questions from exercise 13.2. I hope it is clear for you all, and I request all the students to solve these questions in a separate sheet of paper. And while solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.